All right, we got a John Deere ECM on the bench tonight. Got a few tools hooked up to it. Got the mixing scope. Got the best scope of all time, the HSCOPE. You can see it's decoding those packets pretty fast. J1939 can high and low. And I also got the TEXA running. And kind of a backstory. Me and another tech, a guy that just had a birthday, very good technician, the best, I would say, technician I know, and that is all joking aside. This is why I make those videos. I like guys like him, and I got some family members and friends that like to see this crazy stuff. So anyways, with that justification aside, we'll get to the video here. What I got hooked up here on TEXA is, you can see switched battery voltage and unswitched battery voltage. The reason we pulled this out was this engine was doing the craziest stuff. There was actually two problems, we think, but one of them was some programming issues we got by. Deep Sea had changed some things in the controller. And the second thing was this switched or unswitched battery voltage. Now, I tested this and tried to fix it a couple months ago. What would happen is, I think it was the switched battery voltage was dropping out. Andrew would, well, that guy would remember. One of them was dropping out, and it was hard to catch with the tool because on generator systems, the controller puts out a run and a crank signal, and that run signal is the switched power to the ECM, which brings up communication. I actually got a jumper running to the switched power. When you remove that switched power, the ECM probably goes for another 10 seconds and then powers down. It still keeps that unswitched power, keeping memory and stuff. And it was hard to catch. So what we did, we opened up the harness and I broke out the TEXA power, the power for the TEXA to keep it alive a little more. And we were able to catch that on the times, and this is the problem when it's intermittent. When the engine did not start, it was dropping out switched power or unswitched, either way. And we were like, okay, is it actually dropping out, or is it the ECM? Because when you pull an ECM out, it's a very expensive, repair, and when you go back, you want to be sure. So that's one of the reasons on the bench tonight. It was definitely dropping out, and on site we were 99% sure about that because we had back probed that wiring, that connection, and we didn't see it drop out. We had the scope up, but it's dropping out on the TEXA pit here. So, and we have some schematics, but getting the right schematic, and here's the schematic we were going off of up here. But there were a couple different things that didn't match, so we just wanted to be sure. So we brought this home. It was a bear to open up, and when I got it opened up, you could tell someone's been in there before. These are sealed. You could tell it wasn't sealed back up right, and I could see prying marks. And on the PCB, it unfolds. You could see surface mount components were all dug up. So anyways, I reflowed a connection to either it was unswitched or switched, one of the rails in there, and I've been monitoring it. I monitored it for about an hour when I did the repair a couple months ago, and I've had this running probably 24 hours. Not on TEXA, but I had another logger going out, just making sure the run signal, because when we lost that, we would lose comm. So I think it's repaired, but I'm not really comfortable to put it back in with how dug up it was. So another thing I wanted to show, actually before I show that, I use TEXA because having a OEM software for each manufacturer would just be way too expensive. So TEXA has basically all the on-road and off-road heavy-duty manufacturers under one tool. And John Deere was always known as a hard tool to get, to get access to. They were really locked down diagnostics tools. So anyways, TEXA has done a good job with it, in my opinion. And the biggest thing, you want to be able to make injector calibrations. If say you got to repair the unit and you got to recode injectors, and I've been apprehensive to get to doing that. So now that I got the ECM on the bench, I kind of wanted to. I didn't want to really explore it on site on a working generator, and then all of a sudden remove the injector codes out of the unit, and then make further issues where we got to call the OEM. But it looks pretty simple. Basically, you go in, it tells you have the engine off. It's like, okay, there's your injector coding. You select up or down to scroll to cylinder 1 somehow. Oh, and then, all right, cylinder 4, 3, you can see right here. And hit confirm. Now, you put your codes in and hit enter. So, pretty easy, I think. So the next time we got to do injectors, I might offer to do that. So anyways, I'm going to end communication with this. And the one more thing I wanted to show. You can see we lost activity there. It's not as active. And that's TEXA booting down. So actually you can see I got more activity, but I have more of the same. So TEXA was in control and it was requesting data. So now this thing's just putting the same data out. I think I don't know if it's just, you don't know what it's doing, but it might be polling for something. So you can see the communication is a lot less erratic. And we can look at, we can see the decoded text here going all the way down from all the, you can see all those IDs. And you can see, just to show you, OCF00400. You can see 00400 right here. So you can see HSCOPE doing an unbelievable job decoding also. And we can look at packet data, look at errors, picked up the baud rate of that. So HSCOPE is just an unbelievable scope. You got battery powered if you want, or you can go with a plugged in version. They got a higher voltage version of that. That's the 502. That's the 401 that's isolated. I'm getting sidetracked. So anyways, what I want to show is the importance of a CAN bus terminator resistor. You can see I got a nice square wave packet here. Looking good. We had communication, so we had good communication. On between CAN high and low, you can see we got a 120 ohm resistor right here. It's going right between, there's two of them in a network, okay? Some of them are built into a module, so you might not find an external resistor. And some of them are just little end caps on a harness. Now, I've had people think that those are just dust protectors. Them blanks that you find in the harness. They are not dust protectors. Those, you will lose communication, and I'm going to show you what's going to happen. With two 120 ohm resistors in parallel, you should have 60 ohms on the network. If you test it, that's a way you can test for good circuit integrity. If you don't have a scope, you hear a lot of people ask, if they're having CAN bus problems, what's the resistance are you getting on CAN high and low? It's because those two 120 ohm resistors, it's a standard in the industry. Like I said, sometimes there's external ones, sometimes they're built into the module. So I have some resistors right here between CAN high and low, and I'm going to just have you watch what happens when I remove the jumper for that resistor, and you can see we have no more communication. I would not be able to communicate. So that's just a demonstration of how important the terminator resistor is on your CAN bus network. Very important. It's not a dust cap. This is something that I think techs are going to have to get better at. Even the new air-cooled Generac generator has CAN bus on it. Briggs & Stratton has CAN bus between the little air-cooled generator between the controller and the voltage regulator. Communication diagnostics in generators is important as it is for Modbus. And another thing is what they're doing now is making a controller then displays separately in their RS-485 annunciators. Communication is, to be a generator tech nowadays, you gotta almost be better at communications and obviously electrical diagnostics and control wiring, and engines are down the list now as far as what's important as a generator technician. You're going to need to get into scoping unless you want to be guessing on CAN bus data. It's going to be necessary if you want to go further in this field, in my opinion. So anyways, that's the end of my rant. Just wanted to show some of the fellas out there that are and gals that watch the videos. We got a couple out there. Some good technicians we have. So that's it. That's a John Deere. I don't know what the engine was. Either way, John Deere ECM, TEXA, CAN bus, resistors, all that good old stuff. Merry Christmas.